There's two parts to what we've learned this week. The first part was how to name compounds. And the second part was how to write their formula. So what I'm going to do is I am going to go through, there's two ways I could do it. I could go through how to name for each type and then how to write for each type, or I could go through like how to name and write for each type. And I think I'm going to do the latter. I'm going to, is that the latter? Yes, the latter, not the former. I get this confused. So I'm going to do kind of how to name and write for each type. And so the first section is called ionic compounds, right? And there's a whole kind of section for that. And ionic compounds are what? What are they made of? How do you know? Yes, a metal is involved, and then there's a non-metal, right? That's how you know it's ionic. Within ionic, the general rule for naming, I'm going to do naming in blue, and then writing formulas like in this purplish color. So the general rule for naming, anybody remember? Yeah, you name the metal and you name the whole name, like you don't change anything about it. Name the metal, and then you name the non-metal, but what do you do for the non-metal? Yes, you change it to "-ide". Okay, that's the general rule for ionic. You don't do any subscripts or anything like that, like any prefixes. So as an example, if I said, name this compound right here. First of all, you look at it and you say, okay, this is an ionic compound. It's magnesium, that's a metal, right? And there's nothing else weird. There's no polyatomic ion, there's no transition metal. And so we're just going to do this simple rule. We're going to call it magnesium. And then Br is bromine, right? And so what do we change it to? Bromide, right? Magnesium bromide. So what we don't do is we don't put a di in front. So even though this has a 2 right here, this is enough information to figure out the formula because we know the charge. And so we can do that crossover rule later. And so for ionic compounds, you don't do any prefix. You just write the name of each one and you change the ending to "-ide". When you are naming, within ionic, there's two different types. There's the regular type. And then if you have a transition metal, there's certain things that you do. And then if you have a polyatomic, or that's also called a ternary compound, there's something that you do. Okay, so we'll talk about both. When there's a transition metal, you're going to follow these same steps, right? So it's still the same steps here, but what do you add in? Yes, the Roman numeral. Okay, be really similar steps, except metal, non-metal, Roman numeral in between, and then non-metal, and you change it to "-ide", just like normal. So it's the same thing as above, except you add a Roman numeral. This Roman numeral is the charge of the metal. Charge of metal. So for example, if you had to name Fe, I'm going to do a couple examples. So we'll start with FeO, and I said, name this compound. First of all, you say, okay, I know this is an ionic compound because Fe is a metal. But not only is it a metal, if I look at its location, it's also a transition metal. It's in that D block, right? Transition metal. So I need to put in a Roman numeral to figure out to indicate the charge. So the question is, what charge is it here? What charge does iron have so that I can put that Roman numeral? It's not 1. So you might think it because, oh, this is a 1, and so it came from that, right? It doesn't always work perfectly with the crossover rule, okay? Because what charge does each oxygen ion have? -2, right? And since there's 1 of them, it's just -2. So iron has a +2 charge. So this one was reduced, right? It would have been eventually, like it would have been Fe2O2, right? But it was reduced. And so whenever they're reduced, it doesn't always work like figuring out what this one is, and that's the charge of it. So what charge does iron have if this side is -2? positive 2 to make it even out, because we know that the overall charge has to be 0, right? And so in this case, the name is going to be iron 2, and then oxygen becomes oxide. Okay, I'm going to do one more example here of Fe2O3. All right, so now we're like, okay, this is the same thing, but now there's different amounts of each here. So is the charge going to be the same? Well, there's 3 oxygens, and each of them have a -2 charge, and so this side is -6. That means that this side is +6, okay? So if you wrote iron 6 oxide, what would be wrong with that? What'd you say? It's not simplified. How many iron atoms are there? There's 2, and so but that +6 charge is divided into 2 branches, right? So you divide by 2. 6 divided by 2 is 3. It's actually going to be iron 3 oxide, right? So we're going to cross this one out. Does that make sense so far, how I got the 3 there? The best thing you can do for learning is to follow along enough to where so that you ask questions if you're not tracking. Like, that's a great thing if you can do that. And so let me know if you have any questions. So that's how you name a transition metal. Okay, and then there are rules for naming polyatomics, right? So polyatomics are on the back sheet of your periodic table. Okay, so when you name them, you're going to name the metal and then the polyatomic ion, right? Whenever they're included. And then you'll include Roman numerals if the metal was transition, okay? But you don't change the ending to "ide." This is the only case where you don't change the ending to "ide," unless it's also an acid. Okay, so let's say that you have MgSO4 and I ask you to name it. Okay, first of all, you might be tempted to write magnesium sulfur oxide. That would be incorrect if you wrote this. This is what you should not have. Because whenever there are more than 2, whenever it's not, this two compounds is called binary. So far we've been dealing with binary compounds. 1, 2, 1, 2, 1, 2, right? But now we've got Mg, S, and O. So we're gonna look on our back sheet and find the polyatomic ion for this. So SO4 is sulfate, right? So when we name the polyatomic ion, we name the metal and then the ion. So it's gonna be magnesium sulfate, and that's it. You don't do any prefixes to indicate the charge. You don't, anything extra. So if you had Fe3PO4, right? First you look at it and you say, okay, this is definitely a polyatomic. We'll just take some notes. There's more than one, right? But what else do you notice about this compound? It's a transition metal. So these are 2 notes that you say, okay, there's 2 different little rules that I'll apply. So this means that you'll do Roman numeral, right? You can just take little notes, and then this means you don't change to "ide." Don't change ending. So then we just apply those rules while we do this. So we have to figure out the charge. So what is PO4? What's that? What is that on your ion sheet? Phosphate, and it's got a -3 charge. Okay, and we've got Fe, and we don't know what charge it has. Okay, so if phosphate has a negative, right, and we do this thing, it's got a -3 charge, and how many phosphates are there? Just 1, right? So you might think, oh, there's 4 phosphates there, right? But that 4, it has to do with the oxygen. So if you don't see a parenthesis and then a number, like if you saw like PO43, right? Then there would be 3 of them, and 3 times 3 would be 9. But we've just said it like this. So there's nothing there. That 4 just is connected to the oxygen. So there's just a -3 charge. That means that this side has to have a +3 charge, but there are 3 of them, right? And so they're going to have a +1 charge each, because 3 divided by 3 is 1. So this is going to be iron 1 phosphate. So phosphate doesn't change. We just had to figure out the charge of iron. Okay. And that's how you name polyatomics. So now that we've known, those are the 3 types of ionic, okay? Now I'm gonna review how to write formulas, so I'll do it in a different color. So we're talking about naming, let's talk about formulas. Okay, so let's just say you've got a normal ionic, right? The main thing is that you write the symbol with the charge that it has, and then you make overall charge equals 0. And if you need to, and that's by crossing over, you can do the crossover rule. And you can reduce if subscripts have a common factor. That's another little note. If subscripts have common factor. So I'll show y'all what I mean by that, okay? So let's say for an example that I say, write the formula for strontium, let's say strontium selenide, okay? Strontium selenide. Okay, I'll do this one with you guys, and the next one I'll have y'all practice. So strontium selenide, the symbol, okay, we're at the symbol with the charge, right? That's the first step. So SR and SE, whenever I find it, right? And then we have to find the charges. I look on my periodic table, and I see that strontium's charge is +2, and selenium's charge is -2, okay? So if we did the crossover rule, right, this number would go here, and this number would go here. SR2, SE2. And then this note says reduce if they have a common factor. So there's a common factor here, right? We could divide both by 2 and get 1. You basically just need 1 of each, right? Because +2 and -2 cancel out. You just need 1 of each. So this will be your final answer. What I don't want to see in your final answer are the charges along with it, like SR1 plus, SE1 negative. You don't show any of the charges in your final answer. Okay, so let's try a transition metal one. And I'm going to let y'all try for a minute, and then we'll go through it. So let's say that I give you Cu S and then Cu2S to name those transition metals. Wait, is that what we're doing? No, it's supposed to be reversed. I'm sorry. You're learning how to write the formula for them. So I'll do a different one. Sorry. You can try that if you want later. Have fun with that. So cobalt 2 oxide, and then cobalt 1 oxide. Write the formulas for both of those. All right, let's try the first one together. Hopefully you guys got started on it. Okay, so we're gonna write the formulas, and this is, again, you look at it and you say, okay, this is a transition metal, so I'm gonna write the charge for each one. So what is the charge of cobalt here? 2, because this 2 tells us so. That is where we get the charge. Oxygen doesn't have a number, but we know it, right? Because it's on our periodic table. If you looked at oxygen's group, its charge is -2, right? And so you're going to need just 1 of each, right? +2 and -2. So your answer should be COO, Cu. Okay? That should be your final answer there. Any questions on that one? Okay, so the next one, its charge is just 1, right? We are getting that from here. And then oxide still has a charge of -2. And so if this charge is +1, we're going to need 2 of them to make the charge equal 0, which is what the crossover rule does, right? So it's going to be CO2O1, or just O. Does that make sense? Okay, that's how you name transition. And then the only other formula you'd have to write is for polyatomic. So I'll write this one down. I'm going to say to oxalate. Okay, that's one. And then I'll do one more. We'll say we'll do one that might look, well, no, actually, yeah, we'll do a little different. Strontium arsenate. Okay, y'all tried those, those two, and then we'll work through it together. All right. So you should look at this and notice one thing. You should notice that it ends in 8. Okay, so because it ends in 8, we know it's not on the periodic table. So if you had thought this was oxide, like oxygen, you would be mostly wrong. If it ends in 8 or ite, it's definitely on the back. And there are actually 2 on the back that end in ide as well. There's cyanide and hydroxide. Both of these are on the back as well, even though they end in ide. These are polyatomics that you can find. Just for a note for you guys to be prepared for that. So cobalt oxalate, we find oxalate on the back, right? Did you guys all find oxalate? The formula was C2O4 with a -2 charge. And so we know that. And then cobalt has a +2 charge, right? So we're going to put that right here. So because it's a +2 and a -2, it's just going to be CO, C2O4. Okay. So strontium arsenate, we know strontium has a +2 charge because of its location. Then we find arsenate on our sheet and we see that it's AsO4 with a -3 charge. So what we're going to do is we're going to cross over, right? So it's going to be SR3 parenthesis AsO4 2. So what would be incorrect is if you did this. Something like that, or if you added the 4 with the 6 and made this like, added the 4 with the 2 and made a 6, that would be wrong. So whenever you cross over, when a polyatomic is involved, you put parentheses around it. Okay. Does that make sense? Any questions on that one? Okay, cool. So we have learned how to name all of the ionic section. All right. That was a huge chunk of what we learned. The next section was covalent, and it's really just one category within it. So when you name it, you use prefixes to indicate the subscript. So the mono, di, tri, tetra indicate subscript. Okay, so for example, if you had P2O6, right? 2, the prefix for 2 is di, the prefix for 6 is hexa. So if you don't remember the prefixes mono, di, tri, tetra, all of that, you should have it in your notes somewhere. If you don't, you can find it on Google Classroom or just ask me. So P2, it's going to be diphosphorus. Okay, and then also we're going to change ending to ide again. So hexa for 6, hexa oxide. Okay, and if we have something like SO, this would be sulfur monoxide or monoxide. So when you have a 1 for the first one, you don't have to put mono. If you put mono, it's all right, but you shouldn't put mono for the first one. But you should do mono for the second one on out. So sulfur monoxide, because mono means 1, right? So does covalent make sense so far? Okay, so with naming, it's just the reverse, right? With formulas. So if I said write the formula for sulfur diiodide, right? Or dicarbon tetra phosphide, right? Sulfur means that there's just one S, Di means two, and iodide came from iodine, right? So it's going to be Si2. Carbon has 2. Phosphorus is going to have 4. So it's going to be C2P4, right? So it's just kind of the flip side of this. You look at the prefixes. So this one, you just use the prefixes. That's it. You don't do the crossover rule. Okay, so that should be noted. You don't do the crossover rule for covalent. Okay, so that brings us to what we learned yesterday about acids. So this is everything so far, and then yesterday we learned about acids. So just briefly, I will summarize acids. So you all remember that all acids, for the purpose of this next test, begin with an H. This is not true in real life, but generally and stereotypically, they begin with an H. So the first type of acid is a binary acid, right? Meaning that there are just 2 elements involved. And when that's the case, like let's say that you've got HF, H2S, HCl, these are all just 2 elements, right? Anybody remember how we name these? You're going to put hydro first. Hydroblanchic acid. In this case, we're going to fill it in with fluor because it's fluorine, right? This is going to be hydro, right? And this one too. So this case, it's sulfur, so we're going to hydrosulfuric acid and then hydrochloric acid. So you fill in the name of the element it's involved with for binary. Okay, that's not too bad. Ternary, it's not too bad either, but you have to remember a little bit of extra stuff. Okay, so this is polyatomics. Polyatomics. So if you had If you had H2SO4, H3PO3, HClO4. Okay. First of all, let's just say that I'll kind of put the rules up here. So if your polyatomic ends in 8, you change it to ic. And if it ended in ite, you change it to us, acid, right? So here we have H2SO4. And you notice, okay, there are 3 elements involved. I'm going to look on the back to figure out what this element is. And you find out that it's sulfate. Okay, so sulfate, you change to ic. So it's going to become sulfuric acid. Sulfuric acid. If you said sulfic acid, I wouldn't really count on for it. You should know that sulfuric acid, you should put the whole sulfur name for it. Okay, so you don't put hydro in front. So notice that if hydro was in front, it's binary. If hydro is not in front, it's a polyatomic. So PO3, if you look on your back sheet, that is phosphite, right? So phosphite is going to go to phosphorus. So we're going to call it phosphorus acid because ite changes to us, okay? ClO4, we find it on the back, and its name is perchlorate. So we're going to change it to perchloric acid. Okay, so you need to know this for sure. Ate to ic, ite to us. Oh my gosh. I'm just not a pro at this. Let's see. Oh, isn't that cool? It's turning it green because the color combination. I love that. I remember being in elementary school and being like, I thought it was super crazy that you could mix like the yellow sun with the blue sky and it became green. And I just thought it was the most like mind-boggling thing. I thought it was a magic trick. Okay, so that's how you name binary and ternary. And then now we're going to talk about writing formulas for it. So let me do some examples here. You're going to use the crossover rule for it. Use crossover rule, and then you work backwards, right? So if If it ended in it acid, it had an 8, right? And if it ends in us acid, it came from ite, right? So let me give some examples here and see if you guys can try. So let's say that you have chlorous acid. We're going to try combos of both binary and ternary. Chlorous acid, you've got hydrosulfuric acid. We did that example, I guess, but see if you can do it. Hydrosulfuric acid. And let's say that you've got arsenic acid. Okay, so now you're working backwards. You're trying to find the formula for it. Remember that you use H. H is going to be the first part of it, and you cross over the charges, and you've got to figure out the original polyatomic ion. So I assume everybody's got their ion sheet. I'm going to give you guys like 5 minutes to try. This is probably, at least for me, this was the hardest part, was the acids, specifically the ternary acids, and writing formulas for them. It's kind of combining everything. So I'll give you 5 minutes, do those, and then we'll check the answers together. All right, you guys ready? Did anybody get stuck or did you guys finish? Okay. So chlorous came from what? What is the original polyatomic going on here? Chlorite. Okay, chlorite. And so when we look at chlorite, it is ClO2 with a -1 charge. And so we're going to put an H in front. And so this is enough to make it, you know, we need 1 H, right? So it's going to be HClO2 as your final answer. Okay. Hydrosulfuric acid. And so you might see the ick and think, okay, this is sulfate. But the hydro in front tells you that it's binary, right? Because hydro is only used for just 2 at a time right here. So we're dealing with H and then S for sulfur. But because S has a -2 charge, we're gonna make it H2S, right? Okay, arsenic acid came from what? Arsenate. So if you find arsenate on your list, it's in that 3rd column. So it's going to be ASO4 with a -3 charge, right? So it's going to be H3ASO4. Okay, so your final answer should be in the formatting of this. No extra charges or anything for your grade. Like this is not a final answer right here. So are there any questions about how we got this here? Okay, I'm going to leave this up for a second so y'all can take notes just for 1 second, and then I'll show you what we're going to do next. So yeah, we'll have a quiz on Thursday, test on Friday over all of nomenclature and writing formulas. Okay, so what am I doing? Yes, right here. So some of you have finished your nomenclature worksheet, and because this is kind of a hard section, we wanted to give yet another worksheet just for practice. And so you definitely don't have to do all of these. What I suggest doing is to do like 5 of these and then 5 of these, because you see how these are like opposite. This is how to write formulas, and this is how to write the names. And so if you're only going to do 20 problems total, or 10 or 5, do half of each, right? Because this side and this side are both equal parts of the test. And so if you have not finished your worksheets, you can work on this for extra practice. If you have not finished your worksheets, then you can get it out now and finish. But what I would like you guys to do this time is to raise your hand after you finish like maybe 3 problems and let me check it like every time, because I want to be able to give you guys feedback, and we don't have a whole lot of feedback forms for you guys, like besides the quiz. And so raise your hand and let me know if you let me know after you've done 3 at a time, something like that. Does that sound good? We're going to do this for probably about 20 minutes, and then the last few minutes we have even more to do. So today is kind of a full day. So I'll give y'all 20 minutes to practice through some more of these.